Hello everyone, I Dr. Tarkeshwari Verma from CSV2 welcome you all in this course Fundamental of Engineering Physics. Okay, tell me one thing, how can reach data one place to another place? What? A Wi-Fi? Yes. Internet? Yes. All answer are right. Okay, for this communication what we used? We use some cables. That cable made by fiber optic material. So, today's lecture topic is the introduction of the fiber optics. Let's explore the fiber optics. Today's topic is what is the fiber optics, why fiber optics used, fiber optic applications, fiber optics technology, how fiber optics works, fiber optics cable and connectors, designing fiber optic system, fiber optic installation and outside plant and premises. Fiber optic is simply stand for the flexible glasses as thin as a human hair that is used for telecommunication. These strands carry digital signal with a light. When 100 or even 1000 of these strands are arranged in a bundle, it is called optical fiber. This is an introduction to the technology of fiber optics communication, sending communication over hair thin strand of ultra pure glass, and sometimes it be used as a plastic material. Do you know which is the first communication fiber optics? Let's explore. The first commercial fiber optics installation was for telephonic signal in Chicago, installed in 1976. The first long distance network over operational in early 1980s. By 1985, most of today's basic technology was developed. The end being installed the fiber optic networks that now handle virtually all long distance telecommunication. Optical fibers are thin, long strand of ultra pure glass or plastic that can to transmit light from one end to another without much loss. The glass used to make optical fiber is so pure. If for taking one example, if the Pacific Ocean was filled with this glass, then we would be able to see the ocean bottom of the surface. The light source of the transmitting and the modulated by electrical signal, and this modulated light energy is fed into the optical fiber. The receiving and this light energy is made incident on photosensor, which convert this light signal back to electric signal. In a earlier system, very earlier for the telephone and telegraph use the copper wire for communication, but soon demand outstripped the capacity and capability of copper wires, and data transport got added to voice communication. Then come coaxial copper cables. That teeny strand of optical fiber can carry more communication signal than the large copper cable in the background and over much longer distance. The copper cable has about 1000 pair of conductors. Each pair can only carry about 24 telephone conversation a distance of less than 3 miles. In case of fiber optics, the fiber optic cable carries more than 32,000 conversation, hundreds or even thousands of miles before it needs regeneration. That each fiber can simultaneously carry over 150 times more by transmitting different colors called wavelength of light. The cost of transmitting signal, phone, conversation over fiber optics is only about 1% the cost of transmitting it over copper wire. That's why fiber is the exclusive medium for long distance communication. Fiber optics everywhere we use, like our land and under the sea. Fiber optics is the backbone of our world of communication. With the understand cable connecting with this cable connecting the contents and the landline connecting everywhere else. Fiber optics used in a telecom, the internet, CATV, wireless, security, oil and gas, production, alternative energy, computer network, etc. Telephones including circular wireless, internet, LANs. There are many more examples are available in our daily life to where we use the fiber optics. Topic is introduction of fiber optics. Fiber optics is the technology that involves the transmission of light through optical fibers, usually made of glass or a plastic. It is the widely used for the communication, data transmission, sensing and imaging process. Fiber optic systems offer advantages such as a high bandwidth, low signal loss, immunity of low signal, electromagnetic interference and secure data transmission. Let us know about their historical background. The concept of guiding light through the transparent material dates back to ancient times. However, modern fiber optics earned a 20th century in our 1915. Researchers being experimenting with optical communication using glass fiber. The invention of the laser in 1960 and the development of low loss optical fiber in the 1970s. They were the practical application of the fiber optics in telecommunication and other fields. What is the basic principle behind the fiber optics? The fiber optics relies on the principle of total internal reflection, where light traveling through the denser medium, for example glass, is reflected back into the medium when it encounters a less dense medium like air that an angle greater than critical angle. That phenomena known as the total reflection. This allows light to guided through the core of the optical fiber, minimizing signal loss. The core surrounding by the cladding layer of the lower refractive index keep the light confined within the fiber. There are the many more components of fiber optic system. Let us explore each and every component of the fiber optic system. First one is the optical fiber. Optical fiber are a core component of the fiber optic system. They consist of the core where the light propagates surrounding by the cladding layer to confine the light within the core. The outcome layer may include buffer or jacket for protection. Depending the application, fibers may be also have additional layers such as the coating of the mechanical strength or special material for specific purpose like sensing. Next is the light source. Light source such as a laser and light emitting diodes LEDs are used to generate light signal in a fiber optic system. Laser offer a high coherence and narrow spectral width, making them suitable for long distance transmission and high speed communication. LED are the cost effective and widely used the short distance communication in a local area networks known as the LAN and fiber optics to the home application also. Next is our component is the detector. Detectors such as the photodiode convert light signal back to electrical signal at the receiving end of the fiber optic system. These detectors must be sensitive to our wavelength of the light used in the system. Silicon based photodiodes are commonly used for visible and near infrared light detection, while over material like indium, gallium arsenide are used for long wavelength in infrared spectrum. Connectors and splices are used to join optical fiber or connector to the other component in an optical fiber network. Common type of connector including SC, subscribe connector, lucent connector and straight tip. Fusion splicing and the mechanical splicing are two common techniques for joining fiber with minimal loss. Amplifier and repeaters. Optical amplifier and repeaters are used to boost the strength of optical signal in a long distance fiber optics communication system. Erbium doped fiber amplifier are widely used in a long haul communication system, providing application in the C and L band of the optical spectrum. Repeaters amplify the signal while regenerator decodes and retransmit the signal, effectively eliminating noise and disturbance. Next, our topic is the type of the fiber optics. Optical fiber or types of optical fibers. First one is the single mode fiber. Single mode fiber have a small core diameter typically around 9 microns, allowing only one mode of light propagate. This result is low dispersion and allow for long distance transmission with low signal loss. SMF are single mode fibers are commonly used for telecommunication and long haul communication system. Next, our type is the multi-mode fiber MMF that have longer core diameter typically between the 50 and 100 microns, allowing multiple modes of light to propagate, while MF offer lower manufacturing cost and easier coupling with the light sources. They suffer from higher dispersion and the attenuation compared to the small SMF compared to single mode fibers. Multi-mode fibers are commonly used in a shorter distance applications such as LAN and data centers. Next, our type is the plastic optical fiber. Plastic optical fibers are made of the polymers such as the polymethyl and methacrylate or fluoride polymers. They have longer core diameter and are more flexible than glass fiber, making them easier to handle and install. Plastic optical fibers are commonly used in short distance applications such as a home network, automotive system and industrial sensor. Next, our topic is the optical fiber material and their structure. First material is the glass fiber. Glass fiber are made of silica based glasses with dopant to modify their optical properties. They offer low attenuation and high bandwidth, making them suitable for long distance communication. Glass fiber are produced through process such as the modified chemical vapor deposition method and outside vapor deposition method. Next is the plastic fiber. Plastic fiber are made by polymers such as fluoride polymers. They offer lower manufacturing cost and more flexible than glass fiber, but they are suffer from higher attenuation and lower bandwidth. Plastic fiber are commonly used in a short distance application where cost and flexibility are more important than performance. Next, let's start with the structure. Core cladding structure. The core of an optical fiber is surrounding by a cladding layer with a lower refractive index which help confirm the light within a core through the total internal reflection. The refractive index profile of the core and cladding can be tolerated to minimize dispersion and attenuation. Some fibers have additional layers such as the buffer or a jacket for mechanical protection. Protective coating. Optical fibers are typically coated with the protective layer or provide mechanical strength, environmental protection and resistance to moisture and the chemicals. The coating material can be prepared by polyamides or silicon based material. Proper coating is the essential to the ensure long term reliability and performance of optical fiber in a various operating condition. Now our next topic is the light propagation in optical fiber. Our first phenomena is under this section, which is the total internal reflection. Total internal reflection occurs when light travelling through the denser medium to the denser medium and is reflected back to the medium when it encountered a less dense medium. At an angle greater than crucial angle, this phenomena allows to the how to guide it through the core and optical fiber, minimizing signal loss and enabling effect transmission over long distance. Attenuation. Attenuation refers to the loss of signal power as a light travels through the optical fiber. It is caused by factors such as the absorption, scattering and the bending losses. Attenuation is typically measured in a described per kilometer and varies depending on the wavelength of the light and the quality of the fiber. Dispersion, that refer to the spreading of the light pulses as they travel through the optical fiber. It can be caused by material dispersion, which depends on the refractive index of the fiber material, or a waveguide dispersion, which depend on the geometric structure of the fiber optics. Dispersion limits the transmission describe the data rate of the fiber optics system and must be compensated for the high speed communication system. Optical sources and detectors, they are the most important part in a fiber optics. First optical sources is the light emitting diode. LEDs are semiconductor device that emit the incoherent light when forwarded biased. They are the widely used as a light sources in a short distance fiber optics communication system. Due to their low cost, reliability and ease to integration, LEDs that emit light over the broad spectrum of the wavelength, making them suitable to multimode fiber application. Next our source is the laser diodes. Laser diodes are semiconductor devices that emit coherent light when stimulated by an electric current. They offer a high optical power, narrow spectral width and a high modulation bandwidth, making them suitable for a long distance and a high speed fiber optics communication system. Laser diodes are the commonly used in a single mode fiber application. Photodiodes are the another source of the our fiber optic system, that is the also semiconductor device that convert light signal into the electrical signal. They operate in a reverse bias mode and generate a photocurrent and proportional to the incident light intensity. Photodiodes are used to detector in a fiber optic receiver to convert optical signals back into electrical signal for further processing. Next our topic is the fiber optic communication system. First is the transmission mode. Fiber optics communication system can be operate in a various transmission mode including point to point, point to multipoint and multipoint to multipoint configuration. Point to point system are used for simple connection between two points, while multipoint configuration enable communication between the multiple nodes in a network. Multiplexing technique. Multiplexing techniques such as a time division multiplexing and wavelength division multiplexing allow multiple signals to be transmitted simultaneously over a signal fiber. Time division multiplexing divided in the transmitter into the time slot, while wavelength division multiplexing uses different wavelength of light to be carry multiple signal. That system can be accommodated multiple channels, significantly increasing the capacity of the fiber optic networks. Next our topic is the signal processing. Signal processing techniques such as the modulation and demodulation are used to encode information into the optical signal and recover it at the receiver. Modulation technique include amplitude modulation, frequency modulation and phase modulation, each suitable for different type of data transmission. Demodulation technique extract the modulation signal from the optical carriers from further processing. Next topic is the application of the fiber optics. Everyone know they are fiber optics widely used in our daily life. First is the telecommunication. Fiber optics revolutionized telecommunication by enabling high speed data transmission over long distance. Fiber optics networks form the backbone of internet, facilitating the transfer of vast amount of data between users. Optical fiber are also used in a telephone networks, cable television system and mobile communication network for voice and data transmission. Internet and data transmission is the advantage application part in a fiber optics. That internet backbone consists of the high capacity fiber optics cable that optic cable that interconnected major data center and network hubs worldwide. Next is the cable television. Fiber optics are used in a cable television network to transmit video, audio and data signal to home. Fiber to the home networks deliver high definition television, video on demand and interactive services to subscription. Fiber optics cables offer a high bandwidth and the reliability compared to traditional coaxial cables, enabling the delivery of the high quality multimedia content to the consumers. Medical imaging and endoscopy. In a field of medical, the fiber optics play a very crucial role, like medical imaging process endoscopy application. Fiber optics endoscope allow the doctors to visualize internal organs and perform minimally invasive procedure organs and perform operation and their procedure with the high quality data. Optical fiber are also used the medical diagnosis devices such as a pulse oximeter, blood glucose monitor devices and laser surgery system for the therapeutic and diagnosis purpose and laser surgery system for the laser surgery system and also use the diagnosis many more disease. Used in industrial and military application. Fiber optics find the application in various industrial and military environment due to their reliability, security and immunity to the electromagnetic interference. They are used for the sensing, imaging, lighting and communication in a harsh environment such as oil and gas exploration, aerospace and defenses. Fiber optic sensors are also used to structure health monitoring, temperature sensing and vibration sensing in industrial and military application. Fiber optic sensor. Let us explore what the principle of the fiber optic sensing. Fiber optic sensor detect the changes in a light intensity, phase or a polarization of the measure the various physical, chemical and biological parameter. They offer advantages such as a high sensitivity, immunity to electromagnetic interference and remote sensing capabilities. Fiber optic sensor can be classified into two different types based on their sensing mechanism, including intensity modulated sensor and phase modulated sensor and polarimetric sensor. Application in various industries. Fiber optic sensor find application in aerospace for structural health monitoring of aircraft components, in automotive for the monitoring in engine performance and vehicle dynamics, in healthcare for monitoring of and detecting biomarkers, in environmental monitoring for measuring air and water quality, and structural health monitoring for detecting defects and anomalies in a civil structure such as a bridge and buildings. Challenges and future developments in a fiber optics. Loss mechanisms in an optical fiber include absorption, scattering and bending losses. Absorption occur when light is absorbed by the impurities in the fiber material, while scattering results from irregularities in the fiber structure. Bending losses occur when the fiber is bent beyond the minimum bend radius, causing light leakage. Signal degradation in an optical fiber is caused by attenuation, dispersion and the non-linear effect. Attenuation refers to the loss of the signal water in a light travel through the fiber, while dispersion results in the separating of the light pulses over the time. Non-linear effects such as the self-phase modulation and four-wave mixing can be distort the signal. Bending and microbending losses. Bending and microbending losses occur when the fiber is subjected to stress or strain, causing the variation in the refractive index and light leakage. These losses can be minimized by using fibers with low band sensitivity, proper cable management technique and careful installation practices. Let's summarize our today's lecture. Fiber optics is the transmittive technology that has the resolution communication, sensing and instrumentation across various industries, from the telecommunication and the internet backbone to biomedical sensing and industrial applications. Fiber optic contain to drive innovation to enable new application with a high bandwidth, low latency and immunity to electromagnetic interference. As a research and development effort, the contain to advanced fiber optics will play very important role in shaping the future of the connectivity, information exchange and scientific exploration. So, dear learners, today we understand what is the fiber optics, how its work and their different types of component. Hope so you understand today's lecture very well. Thank you for your patience. Thank you so much.